Mathematically, we know the acceleration can be found by doing the net force divided by the mass. But let's look at the direction of force and how it affects the actual motion of the object. So in this first example, our object is moving at a steady speed. We're going to apply a force in the direction it was originally moving, and you'll see the object will gain speed. If we reverse the direction of the force, so that the force is against the original motion of the object, then the object will lose speed. The object eventually stops. Had we not removed the force, the object would have changed direction and gained speed as it moved back toward its original location. Okay, now we'd like to have the force permanently facing in the negative y direction. So as our object moves in the x direction, the y direction force will not slow it down in the x direction, but will deflect it so that we'll gain speed in the y direction. So again, the object will continue traveling at its original speed in the x direction, but will be increasing in speed in the y direction. This object will follow a parabolic path similar to the path followed by a projectile. So again, we do this a little slower. The object has the force applied to it, and it's going to follow a parabolic path. And you can see how the object increased in speed as time went on. We are now going to have the force stay perpendicular to the object's motion. So although it looks similar to the projectile case at first, you'll notice that the force will not stay pointing toward the negative y-axis, but this time the force will alter its direction to stay perpendicular to the instantaneous direction that the object is traveling. So when the object is here, it was traveling up. When it's here, the object is traveling left. Realize at all moments the force is perpendicular to the direction of motion. This is the condition that will lead to perfect circular motion. The object will not gain speed, it will not gain energy. All that will happen will be that it changes direction.